So today I will be concentrating on the zone plate. This is particularly known as Fresnel's zone plate. So why it is known as Fresnel's zone plate? Because it works on the principle of Fresnel's half period zones. I think you today know by this time you already know about what is half period zones, what is the net amplitude due to all the half period zones, what is the radius of it, what is the area of it, everything you know. See, zone plate is one of the optical device. Like your lens, you have seen convex lenses and you have seen prisms, correct? So, like your optical device, zone plate, like other optical device, zone plate is also one of the optical device which is made up of glass, but here which uses the phenomenon of diffraction of light. See, in the convex lenses, the phenomenon of light used is refraction, correct? And similarly in the mirrors, the phenomenon used is reflection, correct? Similarly in the zone plate, in which this optical device, we will use the diffraction, particularly like half period zone diffraction, what you have seen there, the same phenomenon is used in the zone plate. That is why the zone plate is also known as Fresnel's zone plate. So how to construct this Fresnel's zone plate? So you already know that Fresnel's half period zones radius is proportional to the square root of natural numbers, correct? So for example, if I consider first natural number 1, then root of 1 is 1, correct? Next, second natural number 2, then root of 2 is something like 1.41 you will get, correct? And 3, so then root of 3 is 1.71 you will get. Similarly, if you go on like this, root of 4 will be 2. Similarly, you can go on like this. Take a white sheet. How to construct the Fresnel's half period zones? Take a white sheet. On the white sheet, construct the concentric circles such that first circle is of say 1 centimeter, and then the second circle will be 1.41 centimeter. Okay, and the third circle will be 1.71 centimeter, correct? And next will be 2 centimeters. See, if you go on like this, actually the distance between the zones goes on decreases like this. See, the distance between the zones goes on decreases if you construct like this. Okay, now what I will do, I will black all the half zones. See, for example, this is known as first zone, and this is second, and this one will be third. Next, this one will be fourth, something like that. So if I blacken, or if I paint black painted, all the half odd zones are black painted like this. See, if I do like this, first zone is painted, and then second zone is transparent, and the third zone is painted, and the fourth zone is painted like this. So if I do this, and then if I take the reduced photograph of this on a very tiny glass plate, reduced very small tiny photograph of this on a glass plate, then what happens? And this negative of the glass plate is known as a zone plate. This is how the zone plate is constructed. See, in this negative, whichever is painted that appears to be transparent, and whichever is transparent on the white sheet that appears to be blackened, correct? See, you have seen your photo and negative. In earlier this, there will be photo and negative. Nowadays you have so many equipments to take your photograph. So I don't know whether you have an idea of negative or not. In earlier days, firstly they will develop negative, and then they will give your exact photograph. So in the negative, what happens? Whatever is blackened, that will appear as white here. Similarly here, whatever is painted, that will appear as transparent. Therefore first zone appears as transparent, but the second zone, which is transparent, appear to be blackened, and the third zone, which is blackened, now it appears to be transparent. So like this. And this type of zone plate is basically known as positive zone plate. Why it is positive zone plate, or it is also known as odd zone plate, I can call this as. Why this is known as odd zone plate? Because all the odd zones are transparent and the even zones are blackened. Similarly, I can create a negative zone plate, and in the negative zone plate, all the even zones are transparent but the odd zones are blackened. Since the middle one is known as the first one, which is the odd one, so in the odd plate, the middle ones should be transparent, correct? And in the even plate, the middle one should be blackened. So I can also call what is positive zone plate means the zone plate in which the central zone is transparent is known as positive zone plate. The similarly, what do you mean by negative zone plate? That zone plate in which the central zone is blackened or opaque, that is known as negative zone plate. So zone plate is like optical device like your lens, mirror, etc., which works on the principle of diffraction. Particularly, it works on the Fresnel's half period zones. So we know that in the Fresnel's half period zones, the radius of each zone is proportional to root of natural numbers. So if I construct the concentric circles whose radius is proportional to the root of natural numbers on a white sheet, and then if I take a very reduced photograph of that on a glass plate, then I can get the zone plates. And zone plates is of positive and negative, two types, positive and negative. Positive is one in which odd zones are transparent, or this can also be treated as in which the central zone is transparent. Negative zone is one in which even zones are transparent or the central zone is opaque. I can define like that also. So this is about the construction of the zone plate. Now you have to take down the notes. So please take down the notes quickly. Zone plate. So it is a special diffracting device used to demonstrate the diffraction effect experimentally. Construction. First point, to construct a zone plate, a series of concentric circles with radii proportional to the square root of natural numbers, that is Rn proportional to root n, are drawn on a sheet of white paper. Second point, the alternate odd numbered zones are painted black. A highly reduced size photograph of this pattern is taken on a glass plate. The resulting glass negative is known as zone plate, or the glass photograph you can take like that. See here, the zone which are painted black appears to be transparent because this is the negative of the white paper. Okay. So since we painted odd numbered zones which appears transparent in zone plate and are known as positive zone plate. Similarly, we can construct a negative zone plate also. They may ask you what are zone plates? Give the construction of zone plate. Now what do you mean by positive zone plate? The zone plate in which odd numbered zones are transparent. Or I can also define like this, the zone plate in which central zone is transparent. Similarly, I can define the negative zone plate. The zone plate in which even numbered zones are transparent, or zone plate in which the central zone is opaque. Now you have to write the figure for positive and negative zone plates like this. So central zone is transparent, therefore this is known as positive zone plate. So you can write like this. Next, the central zone is blackened, so you have to write the negative zone plate like this. Okay. Now, working or theory of the zone plate. See, imagine this is your zone plate. This is your zone plate, and you have held the zone plate like this, perpendicular to the plane sheet. Then what happens? Then how can I write that? If you consider here the central part, here the central part will be, if it is odd, if this is transparent, then the next plate will be something like this. Or in other words, I can write like this. See, central part is transparent, and next this is blackened one. This is transparent, this is blackened. Like this, I can write up to the last zone, mth zone. Okay, and in the downward also I can write, but I am not showing in the downward. So you have to write the zone plate in the cross-sectional way. So in the cross-sectional way, I can write like this. So this is the zone plate, central one, and then what happens, next is opaque, next is transparent, and then to next is opaque, and then next is transparent, then to next is opaque, something like this you have to go on showing. Okay, now I will consider a source point here. So it will emit the light rays. So what happens when the source come to the edge of the opaque point? You know that diffraction means the light bends around the edges of an obstacle. Now this is an obstacle. So at this edges the light bends. Okay, it will come like this and then it will bend like this. Come like this and it will bend like this. So similarly, this is the another edge, it will bend like this, it will bend like this. So finally, at the last edge, it will bend like this. I can show like this. See, since all the light rays will meet at the point P, the point P will become a real image point of the object S, correct, or the source S. Okay, now, and I will call this point as O. Okay, and the distance between the source and this device is considered as A, and device to image point is considered as B. So you know that from source to lens is considered as object distance, and lens to image is considered as image distance. Therefore, I can consider this as object distance A and the image distance B. Usually, object distance will be represented by U and image distance will be represented by V. But in the diffraction, we will represent object distance by A and image distance by B. Okay. Or if you are having any confusion, you can represent it with U and V. No problem. Okay. So, this is the diagram which explains how the working of the zone plate takes place. Now related to some derivation is there, that is known as theory of zone plate, that I will be writing here. So you have to explain all this. Consider the cross section of the zone plate like this. Let S be the source. The light emitting from the S will diffract around the edges of an obstacle and it will meet at a point P. You have to write all these initial details. Okay. Next, what I can write? See, this is one light ray. For the first zone M1, M2, M3, this is M4 point. Like that I can write up to Mn. You know that since it works on the principle of half period zones, the any two light rays which is coming from one zone to the next immediate consecutive zone will have the phase difference or path difference of lambda by 2. You know that. Therefore, I can write like this. S M1P minus SOP. S M1P minus SOP can be written as lambda by 2. Correct, according to the principle of half period zones, and this is the zone plate which works on the principle of half period zones. See, SM1P can be written as SM1 plus M1P. Okay, that is what I have written here. Similarly, SOP can be written as SO plus OP. That is what I have written here. Okay, now what I will do, SM1P plus M1P is equal to SO. I will take this to this side, so it becomes SO plus OP plus lambda by 2. So I can write SO means A. See, SO means A, OP means B, image distance B. If you want, you can write U and V also. U plus V lambda by 2 or A plus B lambda by 2. This is for the first zone, M1 zone. Similarly, for M2 zone, what I can write? SM2P will be equal to SM2P minus SOP. If you go on doing in the same steps, then what I will get? A plus B 2 lambda by 2. Because from center to next zone will be total 2 lambda by 2 will be there. Similarly, from center to third zone, lambda by 2 plus lambda by 2 plus lambda by 2, you will get 3 lambda by 2. Similarly, for nth zone, I can write SMN plus MNP will be equal to N A plus B N lambda by 2. I will call this as equation number 1. Okay, now from this figure, this will form a right angle triangle. SMNO will form a right angle triangle. So, from this right angle triangle, I can write SMN square is equal to SO square plus OMN square. You only know that SO is nothing but A square and OMN is nothing but the radius of the nth zone, Rn square. Then if you want SMN, I will take the square root on both sides. A square plus Rn square whole to the power of 1 by 2. I will take A square common inside this. So, I will get 1 plus Rn square by A square. By using binomial theorem and neglecting the higher order. Now only you know that in the previous derivation, you know that what is binomial theorem. See, binomial theorem means 1 plus x whole to the power of n can be written as 1 plus nx plus nx square plus next cube term will come. I will neglect all the higher order terms. I will retain only the order of first. So this is something like taking the power inside. If you neglect the higher order terms, this is something like taking the power inside. So if I take the power inside, I can write like this: 1 plus rn square by 2a square. Now if I multiply a, I will get a plus rn square by 1a get cancels 2a. I will call this as equation number 2. See, in the equation number 1, I have to substitute for Smn and next for Mnp. So, Mnp also from the same method, but by using this right angle triangle, Mn, O and P, I can derive like this. This is with A. For Mnp, you will get B. If you use the same method, you will get the same expression. Mnp will be equal to B plus Rn square by 2b. Now, I will substitute the value of these two, that is equation 2 and equation 3 in 1. So, what I will get? A plus Rn square by 2a plus B plus Rn square by 2b is equal to A plus B plus n lambda by 2 I will get. See, here also A plus B is there, here also A plus B is there, get cancels. So, I will get Rn square by 2a, Rn square by 2b is equal to n lambda by 2. 2 will cancels in all the side and I will take Rn square common. So, remaining will be 1 by a plus 1 by b is equal to n lambda. Or if you want 1 by a plus 1 by b, that can be written as n lambda by Rn square. So, you know that this is 1 by a is object distance 1 by u and 1 by v is image distance 1 by v. You know that 1 by u plus 1 by v is equal to 1 by f. Correct? Therefore, I can write this as 1 over Fn, where Fn is the focal length of the nth zone. Because this is, I am constructing, I have taken this expression only for the nth zone. So, this I can call this as focal length of the nth zone. So, if I write the expression for focal length, I will get like this: Fn is equal to Rn square by n lambda. So, this shows that Fn depends on the n value. For the first zone, different focus is there. For the second zone, different focus is there. So, you know that convex lens means for a given lens only one focal length, but this optical device is different, zone plate is different, it has the multiple foci corresponding to the different zones. Okay, so this is the expression for the focal length of the given zone plate, and thus zone plate will also behaves like a convergent lens, that is convex lens, but the only difference is here it has multiple foci. Instead of single focal length or single focal point, it has different or multiple foci for a given wavelength lambda. Okay, so this is the construction and working of the zone plate. Next, we will be concentrating on the radius of the zone plate. I already told you it is proportional to radius of the zone plate Rn proportional to root n. But I don't know what is that proportionality constant. So from this expression I can find the proportionality constant. See, I can write like this: 1 by a plus 1 by b is equal to n lambda by Rn square. So if I simplify this, I can write a plus b by ab is equal to n lambda by Rn square, or in other words I can write Rn square as ab n lambda by a plus b, correct? So sorry, this is ab lambda by a plus b into n. I can write like this. So if I take only Rn, the square root of ab lambda divided by a plus b into root n. So this shows that Rn proportional to root n, which the constant of proportionality is root of ab lambda divided by a plus b. So this is the constant of proportionality, and this also proves that Rn is proportional to root n. So now if I consider the area of the nth zone, area can be written as pi of, if you want nth zone, I have to write pi Rn square minus Rn minus 1 square. Why this is? You know that nth zone directly considered as pi, directly cannot be considered as pi Rn square. It has to written like Rn square minus Rn minus 1 square. Why? Because So if you have a zones like this in between area is known as the zone, annular area is known as zone, correct? So I cannot consider completely. If you want to do this, then you have to do second area minus first area. That will give you this remaining area, correct? Remaining are the annular space. That is what I have written here for nth zone, pi Rn square minus Rn minus 1 square. Rn is nothing but, now only we have Rn square is nothing but AB lambda by A plus B into n. So AB lambda by A plus B into n. Therefore Rn minus 1 will be AB lambda by A plus B into n minus 1. So if I take pi is already common. If I take this term AB lambda by A plus B, then I can write n minus of n minus 1. So n plus n minus n get cancels. So you will be left with only pi AB lambda by A plus B. So that means here there is no n term. That means all the zones, whether it is first zone, second zone or third zone, so all the zones in the zone plate will have the area, that means which is independent of the term n. That means the area of each zone is same. Since it works on in the Fresnel soft period zones also, you will get the same like this. So in the zone plate also you will get the same. All the areas of all the zones will be same. Okay. Next, coming to the focusing. See, you know that in the Fresnel soft period zones, the total amplitude can be written as A is equal to amplitude due to first zone minus of amplitude due to second zone plus A3 minus A4. You know why I have written like this? Because each zone is having the path difference of lambda by 2. Now I am completely covering A2. That means no amplitude from A2. I am completely covering A4, therefore no amplitude from A4. So if I neglect all the even zones, because I have considered the positive zone plate, so I can write A is equal to A1 plus A3 plus A5 plus etc. See, when I consider all the zones into account, on simplifying this, you know that finally you will get A is equal to A1 by 2. This is the important results of the Fresnel's half period zones. But here I am getting A is equal to A1 plus A3 plus A5 etc. So what it shows? This is A1 by 2. So the resultant amplitude, if you consider all the zone into account, you will get A1 by 2. But if you consider alternate zones into account, then you will get like this, A1 plus A3 plus A5. See, which is much greater than A1 by 2. All the zones A1 by 2. Only odd zones you will get A1 plus A3 plus A5, which is much greater than the value of A1 by 2. That means the point P is extremely bright point. Consider the resultant amplitude is much, but if alternate zones are considered, the resultant amplitude is much greater. Hence, point P is extremely bright point, and that point behaves as a real image of S. So, if you get a point P, if you are observing the point P, at the point P you are getting a extremely bright point, and that point is considered as the real image of S. So, since it is giving the real image, I can call this as the zone plate behaves as a convex lens. Okay. So, this is the focusing action of the convex lens. They may ask you for 2 marks, how the zone plates behaves like a convex lens. So, we have to explain this. So, today I am stopping at this point. So, this finishes of your the concept of zone plate, types of zone plate, construction and working. Next, one more point is there, that is differences or comparison of zone plate with convex lens. Comparison of zone plate with convex lens. Let me make 2 columns. One is zone plate and another one is convex lens. You only can tell the differences. What are the differences? First of all, zone plate is an optical device which works on the principle of diffraction. Correct? But here it works on the principle of refraction. So you should go on listing these differences. Okay. Next, what I can write? So here the expression for the focal length, what I will get? 1 by f is equal to, now only I got, what is the focal length expression? Rn square by n lambda, correct? That is 1 by f is equal to, or f is equal to, 1 by f is equal to n lambda by Rn square I got, correct? The expression for focal length, n lambda by Rn square. Here what is the expression for focal length? 1 by u plus 1 by v is equal to 1 over f. Correct? This is the second difference. What is the third difference I can make? Actually, this is Fn. It has multiple foci. It has single focal point. Correct? Multiple foci. Foci is the plural form of the focal point or focus. And it has the single single focus point. Okay. Fourth one. What is the fourth difference I can make? So you know that in the convex lens, the focal length is proportional to lambda. This point you can take it from second PUC CET portion. See, if there are two colors, red and violet colors, for which one? I have some focus point here. Sorry, wait. So for red you will get the more focal length, for violet you will get the less focal length. This concept is there in your second PUT, you can check. But here the focal length, see in the formula only, Fn is inversely proportional to lambda I can write. Focal length is inversely proportional to lambda. And what is the fifth one I can write? So any other differences? See here, all the light rays which will meet will be in phase. Correct? Since I am explaining, please take down. Since I am having focus problem. See here, all the light rays which will be having the phase difference of lambda by 2. Correct? That is one more difference. And I can write basically the intensity. If you concentrate on intensity, the intensity formed by zone plate will be less, but the intensity formed by the convex lens will be high. So anyway, these are some comparison of the differences between the zone plate and the convex lens. What I have given and what I have explained, you have to write in the form of a notes by using these points. Okay, anyway, I will stop at this point. In the next point, in the next video I will continue. Okay, thank you.